I'd like to welcome our last speakers in this session, Hannah Thevapalan and Scott Armstrong. Hannah is a facade specialist and project manager at WSP Canada. She has over 8 years experience in building science in New York City and Toronto, with the exposure to a variety of commercial, institutional, and residential projects. And she has experience in managing multidisciplinary teams, very detail-oriented projects, and got a Bachelor of Architectural Sciences and a Master of Building Engineering degrees that give her the background and the tools to do this sort of work. Scott is a Senior Facade Specialist at WSP Canada. He's also passionate about buildings and performance, deterioration, and failure, and ultimately renewal. And his projects have spanned commercial, institutional, heritage, recreational, neighborhood development, from Canada to the Caribbean to the Middle East, which is a lot of climate zones, so I'm interested to hear about that. And he has over 20 years experience in high-performance buildings, enclosures, facades, roofing, green roofing, integrated design, and he's also a lead professional. So welcome to the...
Thank you. So thanks for having us here, and we know it's towards the end of the day, so thanks for your patience as we share these next 10 to 15 minutes with you. So as Scott mentioned, the focus of this day is on technologies for a low-carbon future, and we're going to go into questioning today, imagine tomorrow, and create the future. And we have a little mantra at WSP is to be future ready. And for those students that are in the room, great choice in program, and keep at it. And hopefully this is useful for you in terms of seeing what's out there. I'm just going to go over a little overview of what we're going to cover today. We're going to talk about our changing building landscape, our changing climate, as we all are aware of, so we won't spend too much time on that. Our existing buildings and new buildings, and how the differences of embodied and operational carbon within those two, and how we can approach those, as well as low-energy buildings, as well as reinvesting that embodied carbon. And Scott will dive into that down the line. We'll start off with a fact, and that is that 50% of today's existing building stock will still be in use in 2050. They're still going to be there, and we still need to deal with them. So we can focus on new buildings, and we can focus on designing net zero houses, and that is a great focus. But we also have to deal with what's there, and what do we do with it? And do we tear it down, or do we fix it, or do we think differently about how we deal with our aging building stock? We'll look at a map of Toronto. I know we're here in Waterloo, but we're going to focus in on Toronto for the sake of an analysis. And that is, we have a map that's colored in by age of construction. And we can see that we have a significant percentage of the buildings in the core of Toronto that are built from 1903 up to 1976. And within that, in the core, if you zoom in, you have buildings that within the core are hitting that 40 to 60 year range, and that's the age where building components are reaching the end of their service life. This is a graphic that Scott had crafted, and we're looking at the core of Toronto, and what was the year or current?
That was 1966, I think, when the TD Centre landed in Toronto, sort of like the Space Odyssey obelisk.
And now we're looking at the changing picture that we see here. And what this picture illustrates is that a building that was planted there with no other buildings around it may have been designed for that climate. And now we've introduced a separate microclimate, and we have to start designing for those and not just a building as it is. We've seen similar slides in the past about our changing climate, increasing degree days, increasing daily maximum temperatures, increasing amounts of rainfall. And what this tells us, and what we need to remember as students going into design, as well as consultants and builders, is that we need to start looking at how we design for the future and not just for today, and how we test for the future and not for today. For example, water testing. Are existing ASTM standards designed for the increased 166 days of rain, or are we designing for 30 years ago or 20 years ago, and asking those questions now in the testing committees and thinking ahead, designing and modeling for 2050 and not 2020. And I'll pass it on to Scott.
Thanks, Hannah. So we're gonna shift the conversation a little bit, as I mentioned, to existing building retrofits. And I want us to think about this notion. I think Steve Kemp talked about it earlier. Embodied carbon in buildings is an important aspect of design, but it's often, with traditional design, dwarfed by operational carbon. So the amount of energy you consume over the life of that building is orders of magnitude larger than the initial carbon you embody in that building during construction. The reality is very different with low energy buildings because the operational carbon is very low. And in some cases, I think Steve's example, there's an initial carbon investment, but it's actually a negative carbon operation. So after 25 years, you've paid for the embodied carbon. And I want us to think about existing buildings in that way and understand that those assets contain a significant amount of carbon, and we should not necessarily tear them down and have to expend that carbon again if we can see significant operational savings and sort of change the course of that carbon induction or carbon contribution over its life. This is not a data set per se, it's a representational graphic of what we're talking about. The yellow line is an existing building that we may do at that midlife retrofit. So we may replace the glass like for like, we may fix some seals, we may replace the roof, we may replace metal panels with something else, but we're not making any significant change to the operational efficiency of the building. So that operational carbon will continue on that same steep line out into the future. If we can perhaps expend a tiny bit more embodied carbon, so we're sort of reinvesting in embodied carbon in this existing asset, we can change the operational course of carbon increment, and ultimately, at the long life, so another 50 years out, we've saved that much carbon for that building. And we've not had to tear it down and incur a whole bunch more carbon for a new building that would replace it. So again, just a different way, perhaps, of how we think about existing buildings, understanding that this kind of change in operational efficiency requires significant intervention. This is not for the faint of heart. It's not easy. And in Hannah's example of downtown Toronto, we're dealing with very dense urban environments with a vacancy rate of in the neighborhood of 3 to 4%. So you're not operating on an empty building where you can do as you please and disrupt people. You're bolting systems onto people's place of work. So there is considerable planning required. We have a few case studies where we're just going to give very high level what this looks like in practice. One large project that is currently ongoing, this is Richmond Adelaide Centre, 120, 130 Adelaide. On the left-hand side, 35-story commercial office building, metal panel, glass vision units. On the right-hand side, similar, but a 20-story building, also black metal panels and glass. Some life cycle issues, some panel clips failing, not presenting a life safety issue, but over time, as people replace glass, they take panels off, they put them back on, clips break, they add fasteners, they may compromise the structural movement of the system. Acknowledging that these two buildings will require full IGU replacement, probably within the next 5 to 10 years, there's a significant opportunity to see massive operational savings by doing a little bit more than just replacing the glass. If you replace the glass and put really amazing glass in these lousy framing systems, you're wasting your money. You're wasting your money. So we went to the next level. We're in the process of this in execution. It's design build, where the prime consultant, Flynn Canada, is the design builder. And all of the metal panels are being replaced with spandrel glass, and all of the vision units are also being replaced with new vision units in a pre-glazed, panelized cassette system that is bolted onto the existing curtain wall framing. In that process, we're also increasing thermal break size, we're improving air leakage, we're addressing panel failure issues, corroded backpan issues, air leakage issues, and other water infiltration problems. So all of these things are being solved by this exterior retrofit in fully occupied buildings. And we can see from from data analysis on these two buildings that we're seeing anywhere from 30 to 60% improvement in either spandrel U or, well, spandrel R or window U value. And we're also seeing significant percent savings in solar heat gain coefficient. So we're improving comfort. We're perhaps setting these buildings up for a new future climate reality where there's going to be hotter days for longer and more solar heat gain, so changing the dynamics of these buildings. Also, very briefly, this is 401 Bay, another high-rise building downtown Toronto at Queen and Bay. It's a quiet neighborhood, you know, it's a few low-rise buildings and not very many people around. And this building, also same thing. So a number of issues with the existing system, not necessarily very energy efficient, 1960s era construction, precast concrete cladding, single glazed aluminum frame windows, air leakage problems, usual comfort issues. This building is being completely overclad. There's also a stabilization program going on to ensure that that precast stays on the building, and we're improving the insulating value on the outside of the building. There's even more dramatic savings with this particular building. So for the spandrel U is improving by 50%, and the vision U is improving by 72%. So year over year is a $750,000 energy savings from the overcladding. That is not to say that these projects will pay for themselves through energy savings. These are multi-million-dollar projects that do not get paid. You can't have an argument about energy efficiency in commercial office buildings and envelope retrofits. You can barely have that conversation when it comes to initial U value and R value. It's about comfort, it's about safety, it's about durability, it's about climate future reality, and it's about maintaining and improving existing assets and competing with a new built environment that's surrounding all of these buildings. So there's a whole real estate piece that goes into that. The last one I'm going to touch on very briefly is the OAA headquarters. This is a net zero target retrofit. Interestingly, this particular building, the grid, the superstructure grid that's on the roof, was initially designed to receive solar panels in the 1980s when this building was initially built, but solar panels were not readily available, too expensive, and were never installed. As part of this project, we are installing solar panels on this roof grid system because it's designed to take it, and that will be part of the energy offset for the building. So there are a number of strategies. Air sealing, it's already an airtight building, so we have to make sure all of these things that we do to the enclosure don't compromise that airtightness. Installing solar dynamic glass, as I mentioned, renewable energy, and trying to recreate that airtight building. And as I mentioned, this is a net zero target. Very fast overview, very high level, but to give you some context about the built form reality that we have, commercial office building, high-rise residential. I was curious, maybe this is a side conversation over drinks, curious about doubling down on window wall, even if it is fiberglass. I'm not sure I want to go down that road, or we should go down that road, maybe tread there a little carefully, but all that to say, you know, we have a tremendous challenge with our existing building assets. We have a lot of them. We have significant savings opportunities. The technology is available, but every solution is unique, and every solution requires that creative kind of collaborative approach to make sure that you're seeing the savings that you want to see.
Thank you.
Thanks.
You guys did great. That was fascinating. Thank you. And I think we do have time for one or two questions. So we do. I know we want to get back on schedule, but I expect somebody will be curious. Okay, I have one question then for Hannah and Scott. I'm not sure I fully understand the line at which you go from refurbishment to retrofit to adaptive reuse. Is that fuzzy, or is it? Do you have a pretty strong definition yourselves?
Personally, I don't have a strong definition.
Okay.
Yeah, I mean, there's even lack of definition around, you know, is it reskinning, is it recladding, is it overcladding, is it retrofitting, is it renewing? I don't think it really matters. I think we have to understand what our goal is, where we're headed, what our objectives are. In this case, in these cases at least, we're addressing ongoing performance issues. We have built form reality around. There's a lot of new build that these assets are having a hard time competing with. I equate it a little bit to the initial drive for LEED new construction, and what that did to the downtown existing asset management portfolio was it showed the need for an existing building rating system. And so LEED responded with LEED existing buildings, which is now EBOM, and there was a huge surge in existing building registration and certification under LEED. Mm-hmm. And I think the building renewal is seeing a similar trend. There's a lot of new construction, a lot of very tall, sexy-looking buildings now downtown, and the existing assets are struggling to meet that expectation of quality in a building. And so renewal is certainly a response to that.
Okay,
Yeah.
Thanks very much. That's a great answer. So unless there's a burning question, I think we'll thank you all for coming and excellent presentations. And